Good morning. We're going to move on to 10.3, present value and future value. The concepts we've already reviewed in the previous sections, we didn't refer to things as present value or future value. So this is really not going to be anything new. It's going to be somewhat what we've covered over the last couple of chapters, but now we're just going to change terms. The terms that we'll use will be more generic, more general, so that they can be applied on many other items. And these are the terms that we use in finance. So if you go on to get a four-year degree, you're gonna take a finance class, and the primary terms you're going to be using are present value and future value. To calculate the present value, the present value needed as what you need is a given interest rate. A specific term can be found using a different form of compound amount formula. M, meaning this is what we learned about what the maturity value, which what we're going to learn is that's really the future value. But let's go with the maturity value. M equals P, open parentheses, 1 plus I to the power of N. Now the present value really is the principal. The P is the principal, right? If we modify this formula so that we solve for P equals M over, open parentheses, 1 plus I to the power of N. That is what we can use to solve for future value. M would be the future value, P would be the present value. But lo and behold, just like we learned in the previous chapter, we prefer, in often cases, we prefer to use tables. And the trick to doing this is just like what we learned as well, is we need to know what is the compounding interest rate and what is the number of periods that are going to be in play, okay? So let's look at the specific example here. Betty Clark needs to replace 2 pumps at her gas station in 3 years at an estimated cost of $12,000. What lump sum deposited today at 5% compounded annually must she invest to have the needed funds? How much interest will she earn? So the first question is, what does she need today? Well, that's kind of like the principal. What does she need to deposit today into an investment at 5%? And it looks like it's going to be in 3 years. So we know what she's going, or what she really wants, the $12,000, that's the maturity value. So we're going to go ahead and look at using the present value table. What do we need to know? Well, 5%, but it's compounded annually, so 5% will stay with that. 3 years. 3 years is 3 years. There's no months, there's no quarters, there's no days. So we have what we need. 5% at 3 years, 5% N equals 3. I think the next page has the table. Yeah. So 5% for 3 years, 5% point for 3 years is 0.86384, 0.86384. Let's go back to our problem. We know the future value is $12,000. We're going to multiply that future value times 0.86384, and that's going to give us $10,366.08. When we're trying to figure out how much interest she earned, we're simply going to take the difference between the future value of $12,000 and the present value of $10,000. That difference is $1,633.92. Betty Clark needs to put away $10,366 today in a savings account or some type of an investment account that is earning 5%. If she does that in 3 years, she will have $12,000. Moving on to page 395, the local Harley-Davidson shop has seen business grow rapidly. The owners plan to remodel the shop in 1 year at a cost of $280,000. How much should be invested in an investment earning 6% compounded semi-annually to have the funds needed? So now we know the future value. The future value is $280,000. The question is, what do we need to invest today? It's 1 year. It's a compounded semi-annually. So that throws a little bit of a curve to this. That means if it's semi-annually, that's 2 times per year. So we have to take the 2 and we've got to do the multiply and divide scenario. So when we're talking about the number of periods, well, there's 2 periods in a year, and it's 1 year, so 1 times 2 is 2. So that's the easy part. Even the other one's pretty easy. We're going to take the percentage and divide it by 2 as well. So 6% divided by 2 is 3%. So we can look at how exactly this was computed. 6% divided by 2, that gives us a 3%. Now we have the rate we need. And the number of periods is 1 year times 2 periods per year, which is 2. We look on the table. We're going to look for 2 periods and 3%. Let's go up. Here's the table we're at. We're on the same page as the table. So 3% for 2 years, 0.94260. 0.94260. We'll take the future value. The present value is equal to the future value, 280,000 multiplied by 0.94260. We got that from the table. The amount she needs to deposit today is $263,298. With that deposit today earning 6% compounded semi-annually, she will have $280,000 at the end of 1 year. Moving on to the next example, Radix Incorporated wishes to partner with Korean company to purchase a satellite in 3 years. Radix plans to make a cash deposit down payment in 3 years of its anticipated $8 million cost and borrow the remaining funds from the bank. So the only question is how much money is Radix going to need in 3 years in order to make that down payment? Now, what we're given is that the investment that they can put away today will earn 6% for 3 years. And it is compounded annually. So that's good. That makes life easier. 6%, 3 years, n equals 3, I equals 6. However, before we can go any further, we're not really looking for $8 million. What we're looking for is 40% of $8 million. So first we have to compute what is the down payment. The down payment is going to be equal to 40% times $8 million, and that gives us $3,200,000. So this is our target. This is our future value in 3 years. Now all we have to do is figure out what the present value is of $3,200,000 in 3 years with a compounded annually rate of 6% or interest rate of 6%. So we'll look 3 and 6%. Let's go look at the table. We're going to do this one last time. From here on out, you'll know how that works, so you can always go back. 3 years, 6%, 0.83962. We'll go back to our page. 0.83962 is our factor, multiplied not by the 8 million, but only by the 3,200,000. That's 40%. We figured that out just a bit ago. So that what they need to deposit today in a bank account, earning 6% in 3 years, what they need to deposit today is $2,686,784. Brianna Magruder and Tanya Zobin own Extreme Sports Incorporated, whose value is $120,000 today, assuming normal growth. However, the partners believe the value will grow at 15% per year for the next 4 years. So under the example here, they believe that the value is really $120,000 under normal circumstances. But what they're trying to factor in is that, you know what, there's some things changing in the environment that we think that the company is actually going to grow faster than that. It's going to grow at 15% per year for the next 4 years. They want to take this rapid growth into consideration when valuing the business for a potential sale. So we really have to do 2 computations here. First, under normal growth, we're at $120,000. We have to then project up what the future will be in 4 years. What is the value going to be in 4 years under normal growth? So when they say find the future value of the business in 4 years, we're talking about a 15% growth model. We have the rate. We have the present value of $120,000, and we're going to take that for 4 years. And we're going to figure out what the future value is. Now, there is a future value table, but in this case, we're going to go ahead and look up and use the future value formula we reviewed at the beginning of this section, which is really consistent with our compounding interest formula. $120,000, that's our present value. Think about it, that's kind of like the principal. Times, multiplied by open parentheses 1 plus I to the power of n. We can substitute the I and the n. 0.15 for the I, that's 15% per year, it's annual, so we don't have to convert it to anything. And then 4 is n, so to the power of 4. 120,000 times, open parentheses, 1 plus 0.15, close parentheses to the power of 4. If you compute that using your calculator, I guess we can pull up the spreadsheet here and run the numbers. So 120,000, I'm going to open the parentheses. Actually, I'm going to multiply that. Open parentheses, 1 plus 0.15 to the power of 4. Let's see what happens. 209,880.8. So rounded, you'd end up with exactly 209,881. Okay, so now we've recalculated the future value of 209,881. Now we're going to take that and discount it for the same period of time, the 4 years. Oh, let's go back to what the question that we answered A, but I don't think we read question or part B of the question. Part B says estimate the value, that's today's value, of the retail store by finding the present value of the amount found in part A at 6% compounded quarterly. Okay, so the compounded quarterly throws it up just a hair, just a little bit. So we'll figure out, now we're talking about 4 years, but it's compounded quarterly, all right? So we have to convert the rate, the 6% to quarterly rate. To do that, we're going to first, we're going to take 6% and we're going to divide that by 4. So the quarterly rate is now 1.5%. And then we're going to take the number of years and multiply that by 4 because there's 4 times per year, it's quarterly. 4 times 4, 16. So n equals 16, I equals 1.5. We'll go to the table. I'm not going to go to the table anymore. We'll go to the table. We'll look it up. N16, I 1.5. You will get a factor of 0.78803. 0.78803. We're going to take the present value, 209,881. We're going to multiply it by the new factor that we just computed. Actually, we just looked it up. We didn't compute it. We just looked it up. And that's going to be equal to $165,393 rounded. So when they're selling this business, if they truly believe that there's going to be 15% growth, and they can convince a buyer that that's going to be the case, they may be likely or may be better able to sell this business at $165,393. it's a starting point. It's almost like an appraisal. You don't really know for sure what you're going to be able to sell it for. You have to negotiate that. But there's a chance, depending on whether or not the buyers believe that there's that growth potential, that they could sell her for that amount of money. Okay, that ends 10.3. I think that's all the sections. Let me double check. So 10.1, 10.2, 10.3. That's it.